Hey there, 8th grade. In this next video, we're going to review the process for solving multi-step equations. This is something we covered at the beginning of Algebra 1. The basic steps to solving multi-step equations or any linear equation is to distribute, followed by combining like terms on each side, followed by moving the variables to one side, and then finally solving using your inverse operations. Okay, so let's jump right into number 1. We have 6 times the quantity n plus 5 equals 2. Our first step when solving equations is to distribute. So we're going to take the 6 and distribute it to get 6n plus 30 equals 2. We don't have any like terms, and we don't have a variable on both sides, so we can jump right down here to step 4, which says solve, and that means use your inverse operations. So we'll subtract 30 first from both sides to get 6n equals negative 28, and then we'll divide both sides by 6, and we'll get an improper fraction for our answer here. N equals negative 28/6, which reduces to negative 14/3. For number 2, we have 3 times the quantity 5 minus 3x all over negative 4. The first thing I can do is I can distribute in the numerator this 3 to get 15 minus 9x all over negative 4 equals negative 15. When you have an equation like this, it's important to remember that if one side is entirely over a number, in this case we have a denominator of negative 4, you can use the opposite of division, which is multiplication, and multiply both sides by negative 4 to cancel this out. So I can actually multiply first here, and that will just leave my numerator of 15 minus 9x. On the right side, negative 15 times negative 4 is positive 60. From there, I'll subtract 15 from both sides to get negative 9x equals 45. And then I can divide both sides by negative 9 to get x equals negative 5. Okay, number 3, 10a minus 7 equals 21 minus 6a. There's no distributing to do on this one, but there is a variable on both sides. Okay, you see we have a 10a on the left side and a negative 6a on the right side. So I want to get that a on one side using addition or subtraction. So I'm going to choose to add 6a to both sides. And that's going to cancel out my negative 6a. So now we have 16a minus 7 equals 21. From there I can add 7 to both sides to get 16a equals 28. And then I can divide by 16. And I'm going to get a equals the improper fraction 7/4. Number 4, we have some fractions in this problem. 5/6 w plus 21 equals negative 1/3 times the quantity 2w minus 9. I see that I can distribute on the right side my negative 1/3. So that will give me negative 2/3 w, and then plus 1/3 times 9 is 3. The left side will stay the same. Anytime you have more than one fraction in an equation, sometimes it's helpful to multiply every term by the least common denominator of those fractions. So if you look at our fractions here, we have a 6 and a 3. One thing I can do to make my life easier is I can multiply every term by 6, because 6 is the LCD of 6 and 3. So when I do that, on the left side and on the right side, that's going to cancel out my fractions. 6 times 5/6 is just 5, so this will be 5w. 6 times 21 is 126. And then on the right side, negative 2/3 times 6 is negative 4, so we have a negative 4w, and 3 times 6 is 18. Now this equation looks just like number 3 did, so I can go ahead and I can move my w's to one side by adding 4w. That gives me 9w plus 126 equals 18. I can subtract 126 from both sides to get 9w equals negative 108. And then if I divide both sides by 9, w comes out to be negative 12. Okay, number 5, in the numerator, I have 10x plus 17 minus the quantity x minus 9. I can distribute in the numerator, but be careful, we're not going to distribute the 17, we're going to distribute this negative sign here. This is essentially a negative 1. So we end up getting 10x plus 17 minus x, and then our sign changes on the 9 to a plus 9, all over 2 equals 3x plus 1. I can also combine my like terms in the numerator. 10x minus x is 9x, and 17 plus 9 is a plus 26. So we have 9x plus 26 all over 2 equals 3x plus 1. Now I can do the same thing in this next step that we did in problem number 2. I have a denominator on the left side of my equation, so I can multiply that left side by 2 to cancel out that denominator. And when I do that, I need to do the same thing on the right side, multiply it by 2. Notice this is a quantity on the right side, so I need to put in some parentheses so I remember to distribute that 2 when I multiply. So on the left side, I'm left with just that numerator, 9x plus 26. On the right side, I get 6x plus 2. I can subtract 6x from both sides, and that's going to give me a 3x plus 26 equals 2. And then finally subtract 26 from both sides. I get 3x equals negative 24, and dividing by 3, x equals negative 8. Okay, for number 6, I want you to pause the video and I want you to try this one on your own. Don't get freaked out by the fractions there. Okay, the steps work the same. Once you think you have a correct answer, I want you to go ahead and click play to check. Okay, so for this equation, if you solved it correctly, you should have an answer of a equals negative 16/7. Up at the top, you can distribute your 9/8 on the left side and your 3 on the right side to get what I have here in orange. I have fractions on every single term. You notice your denominators are 2, 16, and 4, so the least common denominator there is 16. So if I multiply each of these fractions by a 16, I cancel out my denominators, and I'm left with 72 minus 9a equals 12a plus 120. From there, it's the same steps as we've done previously. Check your signs if you missed this one. Try to find your mistake. You should get negative 16/7. If you did not get that and you're not sure where your mistake is, be sure to make a note so that you can ask me the next time you see me in class. Okay, moving on. We do have some special cases when it comes to multi-step equations, so we're going to take a look at those now in 7 and 8. The process for solving these is the same. So I'm going to start by distributing where possible. So for number 7, I can distribute my 5 on the right side to get 5 minus 5c. And then I'll bring down everything else. I have a negative 5c plus 8c on this side. That gives me 3c. So we have 5 plus 3c. And then when I go to move my variable from one side to the other, I can subtract 3c from both sides, and you'll notice that variable goes away not only on one side but also on the other. So you're left with this statement here, 1 equals 5. Anytime your variable disappears completely, you get one of your special cases. Your special cases are all reals or no solutions. Because this is a false statement and 1 is not equal to 5, this is a no solution. For number 8, same process. We'll distribute the negative 8 on the right side to get negative 8x plus 40. I can add 8x on both sides, and that ends up canceling out the negative 8x on both sides. So I get 40 equals 40. This is a true statement, and so true statements, special cases, are known as all reals. 9 and 10 are examples of proportions. For proportions, you need to remember to cross multiply. That's how we solve proportions, is by cross multiplying. So look at your diagonals. I have a 5 and an x plus 4 on this diagonal. So we're going to multiply these. Remember that that x plus 4 really has invisible parentheses around it. So this is 5 times the quantity x plus 4. And then we set that equal to our other diagonal, 3 times 2, which is 6. So now we solve like normal. I'll distribute the 5 to get 5x plus 20 equals 6. I can subtract 20 from both sides. I get 5x equals negative 14. And then when I divide both sides by 5, I get x equals negative 14 fifths. The same works for number 10. Remember that these quantities here have parentheses around them, so I'll cross multiply. 10 times the quantity 2x minus 8 is equal to 8 times the quantity 5x minus 9. I can distribute my 10 to get 20x minus 80, and distribute my 8 to get 40x minus 72. I can subtract 20x from both sides to get negative 80 equals 20x minus 72. And then I just need to add 72 to both sides. That will give me a negative 8 equals 20x. And then I needed to divide by 20. Negative 8 over 20 reduces to the fraction negative 2 fifths. Okay, the last couple of examples are what we call literal equations, and literal equations are those that have more than one variable. For these, the steps are the same. It just means we're not going to get an actual number for our answers. Okay, so for number 11, we have the equation a plus b all over c equals 5. We're solving this equation for b, so that means that we need to get rid of our a and our c on the left side. I'm going to start out by getting rid of my c, since it's a denominator, and I can do that by multiplying both sides of the equation by c. So multiplying on the left side will cancel out that denominator. I'm left with a plus b. On the right side, I get 5c. From there, to get b by itself, I need to get rid of a, and I can do that by subtracting the a from both sides. So this equation solved for b is b equals 5c minus a. For number 12, I have 3x minus 3y equals 24. I want to solve this equation for x. So I'm going to start out by moving my negative 3y term to the right side of the equation by adding it. That gives me 3x equals 3y plus 24. And then to get x by itself, I need to divide by 3. When you divide, you need to divide every term. Just like when we multiply every term. So I divide both the 3y and the 24 by that 3. That gives me x equals, these 3's will cancel, so this is just a y, plus 24 over 3 is 8. As always, if you have any questions over what we just did in this video, make sure those are written down so that you remember to ask those the next time you see me. And until that time, have a nice day. You're all wonderful people.